All right, we got cut off there in the middle of Indian paint fungus. I have not figured out how to stop my phone from shutting the video off when people call me. Thought I had figured that out, apparently not. So, lab in two parts. We're almost done. So Indian paint fungus, we said, was rust red on the interior, and it definitely provides a lot of good wildlife habitat, can cause severe volume losses in stands where there's a lot of white fur. However, as we've been kind of leading up to in this class, we're trying to move a lot of these stands towards less of that white fur, more of the shade intolerant resistant species, larch ponderosa Douglas fir. Now, that's not to say that there aren't sites where white fir is totally appropriate. So higher elevation, moist slopes. So if you've got that white fir as a natural part of the stand, what are you going to do to manage this? And one of the key things you can do is avoid wounding trees. And it turns out another aspect of the ecology, we already mentioned that the fungus, the spore, gets inside the tree by landing on a dead branch, and then the tree grows around it. And the spore then sits what we call quiescent or dormant. And that dormancy will last for up to 50 or more years. So this is pretty incredible. The spore is inside the tree, and if you think about this, when the tree first grows around that spore, where is the spore located with respect to tissues? It's in the sapwood. This fungus cannot live in the sapwood. So it needs heartwood to feed on. Well, eventually that tree turns that sapwood into heartwood as the tree gets bigger in diameter and it starts shutting down xylem that it no longer needs. That heartwood then has got a spore in it. What starts that spore growing? And it turns out that introduction of oxygen into the xylem appears to be the trigger that starts that growing. How do you get oxygen into the xylem? You wound the tree. One of the big wounding factors in cold climates is frost cracking. And frost cracking is a phenomenon where a tree will split open due to cold, freezing temperatures in early growing season when the sap has started to move up in the trunk. So a frost crack is not something that we have any control over, but mechanical wounds such as banging up trees in harvest operations, other sorts of physical injury to the tree can also start this species growing. So if you're, again, a wood manager managing white fir for paper production or timber production, if you manage on 50-year or less rotations, it's unlikely to be a problem. And if you have older trees than that, avoid wounding them. Our last one is one of my favorites from the standpoint of the conch, and this is Schweinitzii butt rot or brown cubicle butt rot, Phaeolus schweinitzii. And this is an example of a conch that was harvested when it was in a fresh state, and that gives it the other name that it's known by, velvet top fungus. And the top is kind of soft and velvety when it's fresh, and it's got bright yellow coloration, kind of a deep reddish orange with bright yellow edges. And this one was found by a student at the height of that state and brought in fresh, so it has dried with some of that color. This one is more reminiscent of an older conch that has been found after it's dried out. And what does that look like? A cow pie. So the other common name for this some folks use is cow pie fungus. Notice that it comes up from the soil most typically, although it can occasionally grow out of the wood. We find them most commonly coming out of the soil. And they incorporate in them any material, and you can see that this is just basically the forest floor grown in to the body of the sporophore, and you can see some bark scales from ponderosa pine, and then all the fir needles on this one, and then there's a little piece of a cone right there, a little pine fir cone. And so whatever's on the forest floor, this fungus will just grow that sporophore around it. Now it's called brown cubicle butt rot for a reason, and that is it starts at the butt and proceeds upward in the trunk. So I said earlier that this was not actually Fomitopsis officinalis. It's actually Phaeolus schweinitzii. And this is a piece of lodgepole pine firewood. This was a basal round right near the ground, and we see this brown cubicle rot proceeding upward. Rarely ever gets more than about 10 feet or so up in trees, although in old growth Douglas fir, I have seen it up 20, 25 feet or more. Why doesn't it go any higher than that? Can it not eat the heartwood? Oh yeah, it can eat the heartwood, but by the time it gets that far up, tree falls over, right? So this is confined to the butt solely because it starts there and the trees just don't hold in there long enough to have it go, 30, 40, 50 feet up. It does provide some wildlife habitat. I've found a number of woodpecker nests close to the ground. Anytime you see a woodpecker cavity close to the ground that goes through some sound kind of sapwood and then into some rotten heartwood, it's almost assuredly schweinitzii butt rot. And this is in all our Central Oregon conifers. Most commonly I find it in the pines, Douglas fir, and juniper are the big ones, but we found it in the abies as well. All right, our last one, as I said, is not in your field guide. And this one I put in our class because it's so important here in Central Oregon. And that is the juniper pocket rot. And it's on your list as Fomes juniperinus. That genus has been changed now to Pyrophomes juniperinus. And it is found throughout the range of western juniper and then other junipers in North America. And I suspect that its ecology is kind of similar to the Indian paint fungus, where it gets in on shade-killed twigs in a variety of locations, and then there's some environmental trigger and it starts to grow. We don't see it in trees younger than about 75 years or so, but after age 75, and that's an approximation, on up into the early hundreds, we see that rot begin to grow and it gets extensive. And it's called pocket rot because it starts in different pockets. You can see on this board sample right here, there's a pocket, right? And then there's a bunch of sound wood. And then here's a pocket, right? And if we flip the board over, we see the same thing on the other side, extensive pockets that appear to be independent of one another that eventually coalesce or group together. So I always like to say, look, this is what saved old growth juniper woodland from the forest products industry. They are not now interested in old growth juniper, nor will they ever be. That's the industrial market now. Some of you may know there is a niche market for all kinds of cool furnishings and rustic stuff, where old growth juniper with its spirals and gnarled limbs and all of that is desirable. And that comes largely off of private lands. And on public lands, we never went through that period where, timber companies cut all the old growth juniper because it was, a great product wood, because it's not a great product wood. There's a lot of problems with juniper. And then specifically, all of the junipers over 24 inches are extensively rotten, no matter where you go, almost no matter where you go. I get a few people every once in a while, oh, I know a spot where there's these junipers and they're this big around and there's no pocket rot. And one of the things you got to be careful of, it's called pocket rot for a reason. This board right here was the result of me milling a log. I cut it down, there was some pocket rot. I bucked firewood rounds off until there was no pocket rot, actually until there was just a tiny little hole. And I thought, all right, I'll measure up 6 feet, buck the log off, and then mill that log. And I bucked off at 6 feet, no pocket rot. Good, we're good to go. And then I put it in the mill and sawed it, and this is what I got, right? So all these pockets are hidden in there, and so when someone tells you that there's no pocket rot, don't believe it until all that wood has been processed into some sort of product. So what's the big ecological ramification of pocket rot? It never kills juniper unless it breaks from snow load, and we do occasionally get heavy snowfalls that'll load up these leaning junipers, and because they're so extensively rotted, they'll break. But it is the wildlife habitat creator. And out in the desert rangelands where juniper is native, we have, bushy-tailed wood rat, not flying squirrel, but American kestrel, northern flicker, pinion mouse, you name it, bobcats, raccoons, a variety of critters will use these hollow junipers. And if you got a 30-inch juniper, 36-inch juniper that's 1,000 years old and is hollow with multiple entrances. It's a virtual wildlife hotel. All right, so that's a quick overview of some of the ID features and some of the ecological values of these different decays. We're gonna cover the sap rot. I don't cover the sap rot in the video because I just don't have good samples of it. It's not one that lends itself well to a really obvious sample. So read page 116 and 117 in the field guide on the gray-brown sap rot. It's got a fleshy conch. It's not real woody like the others. And it does its damage in the sapwood, so it behaves essentially like the heart rots, but it's gonna do it in the sapwood. And the big concern with sap rot is volume loss if you're doing salvage work. And I have lost considerable volume to gray sap rot, or pouch fungus as I like to call it, and it's also called Cryptoporus vulvatus. By the way, the scientific name Cryptoporus means hidden holes, and vulvatus means of a sac. So it's hidden spores, spore holes in a sac is what the name translates as. And so the spore-bearing surface is enclosed in this leathery sac, which pops open at the bottom and the spores come out. But the main way that this gets around is with the insects. And so where do we see it really commonly? On recently killed trees or recently felled trees that have been attacked by bark beetles or wood borers or both. And so as I mentioned, I've lost volume to ponderosa, or in ponderosa to Cryptoporus, because ponderosa commonly has a lot of sapwood. If you're talking about Douglas fir, that's old growth or large diameter trees that have a small amount of sapwood volume, then volume losses may not be too severe. And the Tillamook burn is a great example of an area where they salvage logged for 20, even 30 years after the Tillamook burn. They were able to salvage log some of these big Douglas firs because the sap rot ate away all of the sapwood, and it was only 1.5 inches thick. And if the tree is 40 inches in diameter, there was still substantial volume available. You get a 24-inch ponderosa pine with a big live crown. It may have a heartwood core that's only 6 or 7 inches in diameter. The rest of that diameter all susceptible to gray sap rot. All right, so that'll wrap that up. Make sure that you read over all of these species accounts. Take a look at the lab sheet, and there at the end of the lab sheet, there's a what to know breakdown, right? What I want you to know from these. All right, until next week.